Okay, these are the answers for the multiple choice questions 26 to 34. So this is question number 26, and it's asking you about the graph of y squared equals x squared plus 9. So if you graph it, this is what it will look like. And it's asking about three things. Number one, is it symmetrical to the x-axis? Which means that if you flip it over the x-axis, would it line up like a mirror? And the answer is yes. And then the second choice is it symmetrical to the y-axis? Meaning if you flip it over this way, would it be like a mirror and match up? The answer is yes. And for number three, it's asking if it's symmetrical to the origin, meaning if you flip the piece, a point like over here, over the origin, will it end up on your graph? And the answer is yes. So all three are true, and E is the correct answer. Okay, number 27 is an integral of an absolute value, which we actually have not done, so you're getting a mini lesson right now. So I just don't want you to get this confused with something that we did in class when it looked like this. And then you had to find y prime, which was x minus 1 times the derivative of x all over the absolute value of x minus 1. That's not this. This is you're going backwards. So don't get that confused with that. So let's get rid of that. Okay, so what you have to do for this, and these are not a very popular type of question that you'll see on the AP exam, but I'm going to go over it just in case. So you know how when you have absolute value of x, it could either equal really x if x was greater than 0, or negative x, whoops, if x is less than 0. Okay, so you have to consider that for here. So this part inside the absolute value, x minus 1, is greater than 0 when? Well, it's greater than 0 when x is greater than 1. And if x was less than 1, for example, like if x was negative 1, then it would be negative 2 inside there. So what would keep this positive if x is greater than 1? So what you have to do then is you have to make an integral and say, okay, so it's x minus 1 when x is greater than 1. So that means the interval from 1 to 3. Because you can't do the whole interval from 0 to 3 because it's only good for when x is greater than 1. And then you're going to have to make the other integral that's left over from 0 to 1 of the negative part, which would be negative x plus 1. So you actually have to find those two integrals, add them together to get your final answer. So the first integral will give you an answer of 2. That's an easy integral to solve, so I'm not going to go over that. And the integral of, there should be a dx on each of these. And the second integral would give you 1/2. So if you add them together, you get 2.5, which was answer D, 5/2. It's the same thing. Okay, number 28 we're actually going to be learning in the next couple of days in class, so I'm going to save that for then. But for number 29, this is just really testing you on what your graphs look like. So which functions are continuous? So for number 1, that's just an exponential, and an exponential is always continuous, so that one's good. For choice number 2, that's also an exponential, so that's good. But for number 3, the function is tan x, and hopefully you recall that tan x looks like this, and then there's an asymptote here and an asymptote here, and then the whole thing continues again like this, and then there's an asymptote here, and so on. So that is not continuous for all numbers, so number 3 was not true. So only 1 and 2 are true, and that gives you choice D. Okay, for number 30, this is a U substitution problem. There is no antiderivative of just tan of something. So you actually have to rewrite this. Whoops. You have to rewrite this as sine over cosine. and then either u is either going to be sine 2x or cosine 2x, and you'll see if you make u sine 2x, it's not going to work for you. So u is supposed to be cosine of 2x, and therefore du is going to be negative sine 2x times 2. If you simplify dx, if you simplify that, you get negative 2 sine 2x dx. So if you look at the original, you don't have a negative 2 sine 2x, you just have sine 2x. So you're going to divide both sides by negative 2, and you get negative 1/2 du equals sine 2x dx. Okay, now you're going to go back and you're going to start substituting. So you're taking, whoops, we forgot the dx here. Okay, so you're going to go back and you're going to take out the sine 2x dx, and you're replacing that with this, negative 1/2 du. So now you're left with nothing in the numerator, so there's a 1 up there. And on the bottom you have cosine 2x, but cosine 2x is u. So you're going to take the antiderivative. Here's the negative 1/2. The antiderivative of 1 over u is just ln u, and then plus c. However, you can't leave it in terms of u. You have to go back and replace the u with the cosine 2x. So your final answer should be negative 1/2 ln of cosine 2x plus c, and that was choice B. Okay, number 31 is everyone's favorite topic, related rates. So they're giving you the formula for the volume of a cone, and it says the radius and the height both increase at a rate of 1/2. So the radius is increasing, so dr dt equals 1/2, and the height is increasing, so dh over dt is also, is also 1/2. Okay, it's saying at what rate, so that's find. At what rate is the volume increasing? So find dv dt when the height is 9 and the radius equals 6. So under normal circumstances, you could not just go straight ahead and take the derivative of the volume because you have two variables in there. However, you have nothing to substitute in there, and they also gave you a lot of information, so you'll see you're going to have enough information. So we're going to get dv dt equals, and now you're going to use a product rule. So it's going to be this thing in the pink times this thing. Okay, so it's the first times the derivative of the second plus the second times the derivative of the first. So you take this 2 when you're bringing it up, so you're going to get 2/3 pi r dr dt. Okay, and now we're just going to substitute everything that we have here. So we're looking for dv dt, and you have 1/3 pi. Now r, you were told, is 6. And dh dt, you were told, is 1/2. Plus h is 9, times 2/3 pi r, but r, we know, is 6, times dr dt, and dr dt is 1/2. And then you just have to work all of that annoying math out. And you will get that dv dt equals 6 pi, that was for this piece here, plus 18 pi, that's what you get from this piece here, and that gives you 24 pi, which is choice C. Okay, so don't forget that related rates is everyone's favorite topic. Okay, so for number 32, you're looking at a graph of a derivative. This is f prime. And you have to figure what the original looks like. So the easiest way to do this is to say, okay, if where the derivative hits the x-axis is where there should be a max or a min. So there should be a max or a min at x equals -1 and x equals 1. So look at your 5 choices. And if you look at choice A, there is no max or min happening at -1. If you look at choice B, there is a max happening at -1. If you look at choice C, there's a min happening at x equals -1. At D, there's no max or min. Let's take that out. And E, no max or min. So your choices between B and C. So you're going to pick one of these, whichever one you prefer. I'll just do the -1. And at -1, it was above the axes, and then it was below the axes. So if it's above the axes, that means it was increasing. And then when it's below the axes, that means it was decreasing. So if you're going from increasing to decreasing, you must be a max. Therefore, there has to be a max at x equals -1. So go back to the choices. Does B have a max at x equals -1? Yes. Does C have a max at x equals -1? No. And that's why B is the answer. Okay, so I just realized that this was actually number 33 that I just did, and for some reason I totally skipped over 32, so I'm going to go back to 32 now, which was this. Okay, so that's number 32. So all you have to do is find the antiderivative of this, which is going to be a negative cosine 3x divided by 3. Okay, the reason why I'm dividing by 3 is because if I was just saying it's negative cosine 3x, and I take the derivative of that, it should match that perfectly. Well, when I take the derivative of this, I'm going to get sine 3x times 3. So I have 3 too much, and that's why I'm dividing by 3. Okay, so that's my antiderivative as it goes from 0 to pi over 3. So first I'm going to substitute in pi over 3. So that's what it looks like when you substitute in pi over 3. And then I'm going to subtract what happens when I put in 0. So 3 times 0 is just 0. Okay, so if you simplify, you can see that this 3 and this 3 cancel. So now you're just left with negative cosine of pi over 3. And a minus gives me positive, plus cosine of 0 over 3. Okay, so we're going to solve for cosine of pi first. So it's going to be a negative cosine pi. So you could use a calculator, or if you look at the unit circle, pi is over here. That's the point -1, 0, sine and cosine. So you're looking for cosine of pi, so it's -1. And cosine of 0 is 1. So a negative becomes positive. And you should get 2/3, which is choice D. And we have one more to go. Okay, for problem number 4, this is an area problem, and you're going to need to know which is on the top, which is on the bottom. So actually, if you graph this, the x cubed plus 8 is going to look something like this. Whoops. Not like that. It's going to look something like this. And then I'll do in another color. X plus 8 ends up going through like this. Sort of like this. This is not the greatest picture, but this is the piece you're looking for, because it said it's only in the first quadrant. So by looking at this, you can see that the top one is x plus 8. So I'm just going to label that's the top. and then this one must be the bottom. So remember, the formula for the area is just going to be the top minus the bottom. This is a really ugly color. I have to change this. I just can't work with that. Okay, so it's just going to be the integral of the top, which is x plus 8, minus the bottom. And all we need to find now are our lower and upper limits. So how do you know when they intersect? You set them equal to each other. So x cubed plus 8, when is that equal to x plus 8? Subtract 8 from both sides, and you get x cubed equals x. So you could set this equal to 0, or you could factor, but common sense might tell you that the only way this is going to be true is when x equals 0 or when x equals 1. So those are my limits. And then I'm going to simplify this to get rid of those parentheses. And this is really nice because hopefully you notice that a positive 8 and a negative 8 cancel each other out, and that just leaves you with this. Okay, so I'm going to go to the next page to solve that. So first you're going to take the antiderivative as it goes from 0 to 1. So first you're going to substitute 1 in there, and then you're going to subtract what happens when you put 0 in there, but you're going to notice that it will just give you 0. So we're just going to have 2/4 minus 1/4 gives you 1/4, and that was choice A. Okay, that's it.